Hello! This week we're going to be looking at matrices. Matrices are very useful for solving large systems of equations, which can pop up in engineering quite frequently. This video will focus on matrix operations, so adding and subtracting matrices from each other, and also multiplying matrices together. First of all, let's look at some notation. So matrices are made up of elements, and these elements are contained within brackets. So the brackets can either be rounded brackets, as I have here, or they can be square brackets. I don't mind which you use. So a matrix can be made up of any number of elements in rows or columns. So for example, matrix X, which is shown here, is what we call a 2 by 1 matrix. So it has 2 rows of elements and only 1 column. So we can write that as a 2 by 1 matrix. Matrix A, on the other hand, it has 2 rows of elements and 2 columns of elements. So that is a 2 by 2 matrix. So you'll notice that where we have a matrix that has more than one row or more than one column, we have to essentially label the elements. So for example, if we look at element A21 here, so the first number of the subscript means that we're in the second row. So the first number represents the row and the second number represents the column. So we're in the first column. So that's some common notation that we use for matrices. So we might want to add 2 or more matrices together. And how can we do this? Well, we can only do this if the matrices essentially have the same dimensions as each other. For example, matrix A here has 2 rows, so does matrix B. Matrix A has 2 columns, and so does matrix B. So this means that we can add them together. How exactly do we add them together? Well, it is quite simple. We simply add element A11 to element B11. We add element A12 to element B12. We can also add A21 to B21. And then finally, we can add A22 and B22. So essentially, we add the corresponding elements of each matrix together. The same rules apply essentially if we want to subtract one matrix from another matrix. So for example here we want to subtract matrix B from matrix A. So we subtract the elements of matrix B from the corresponding elements in matrix A. So the element B11 is subtracted from the element A11. The element B12 is subtracted from the element A12. The element B21 is subtracted from the element A21. And then finally, the element B22 is subtracted from the element A22. So let's look at an example. So let's add matrix A to matrix B. Matrix A is 1, 2, 3, 4 plus matrix B, which is 5, 7, 6, 6. So this gives us 1 plus 5 is 6, 2 plus 7 is 9, 3 plus 6 is 9, and then 4 plus 6 is 10. So that's us added matrix A and matrix B together. What if we want to subtract matrix A from matrix B? Well, matrix B is 5, 7, 6, 6 minus 1, 2, 3, 4. So 5 minus the 1 gives us 4. 7 minus the 2 gives us 5. 6 minus 3 gives us 3. And then 6 minus 4 gives us 2. So it is quite straightforward to add and subtract matrices to and from each other. There could be times where we have to multiply a matrix by some scalar number. It's actually quite straightforward to do this. We simply multiply each element of that matrix by that scalar. So for example, matrix A here, we want to multiply matrix A to find 3A. So we simply multiply each element in that matrix by 3. Similarly, if we want to find 4B, we multiply the matrix B by 4, and we do that by multiplying each element in matrix B by 4. Let's take a look at an example. So in this example, we have two matrices, A and B, and we're asked to calculate 3A, so multiply matrix A by 3, and 4B, multiply matrix B by 4. So let's look at 3A. So we have 3 times matrix A, which is 1, 2, 3, 4, and that gives us 3 times the 1 is 3, 3 times the 2 is 6, 3 times the 3 is 9, and 3 times the 4 is 12. So that's the matrix 3A. Let's look at 4B. So 4 times matrix B, which is 5, 7, 6, 6. So we have 4 times the 5, which gives us 20. We have 4 times 7, which gives us 28. We have 4 times 6, which gives us 24. And then we have 4 times 6 again, which gives us 24. So again, it is quite straightforward to multiply matrices by a scalar. It is, however, much more complex to multiply matrices together. The first thing to note about multiplying matrices together is that we can only multiply two matrices together where the number of columns in the first matrix is equal to the number of rows in the second matrix. So for example, matrix A here has m rows and n columns, and matrix B has p rows and q columns. So in order for us to be able to multiply these two together, then n would have to equal p. So the number of columns in matrix A would have to be equal to the number of rows in matrix B. If that were the case, then the matrix that we would end up with would have m number of rows and q number of columns. If n wasn't equal to p, then we could not multiply A and B. We just can't do it. It's not possible. So with that in mind, let's take a look at how we can multiply together two matrices that each have 2 rows and 2 columns. So we want to multiply matrix A and matrix B. So the number of columns in matrix A is equal to the number of rows in column B. So we can do this, and the resultant matrix, let's call it matrix C, will also have 2 rows and 2 columns. So how do we actually calculate what the values of the elements will be in this new matrix C? Well, there is a process that we follow. So matrix C has the 4 elements. So element C11, which is underlined here in blue, is essentially found by combining the first row of matrix A with the first column of matrix B. So you have A11 multiplied by B11, and that is added to A12 multiplied by B21. So that's the first element. Let's look at how we get element C12, underlined here in yellow. We get this by combining the first row of matrix A with the second column of matrix B. So we have A12 multiplied now by A11 multiplied by B12, and that's added to A12 multiplied by B22. The third element we'll look at is C21, and now that's obtained by combining the second row of matrix A with the first column of matrix B. So we have A21 multiplied by B11, and that is added to A22 multiplied by B21. Lastly, the last element that we will look at is C22, and that is found by combining the second row of matrix A and the second column of matrix B. So we have A21 multiplied by B12, and that is added to A22 multiplied by B22. So that's the process that we follow. It does look a little bit complicated at first glance, but once you get to know it, it does become quite straightforward. So let's take a look at an example. In this example, we want to multiply the 2 by 2 matrix A by the 2 by 2 matrix B. So the resultant matrix C will also be a 2 by 2 matrix. So we have matrix A, which is 1, 2, 3, 4, and that's multiplied by matrix B, which is 5, 7, 6, 6. So element C11 will be equal to 1 multiplied by the 5. So that's 1 multiplied by this 5, and then that will be added to the 2 multiplied by 6. So 2 multiplied by 6. Let's not worry about actually getting the final numbers right now. I'm going to skip on to the next element, and then we'll do their final calculations in the next step. So element C12 is now calculated as 1 multiplied by 7 add 2 multiplied by 6. That is this row combined with this column. Okay? Element C21 is now we're going on to the second row of matrix A. So we have 3 multiplied by 5, and that's plus 4 multiplied by 6. Element C22 is now again the second row of matrix A, but moving on to the second column of matrix B. So it's 3 times 7, and that's adding 4 plus 6. So as I said previously, it can get a bit sort of messy and complicated, but try not to be put off by that. Try to just be as careful as possible. Moving on to the next step, let's simplify this. So we have 5 add 12 is element C11. Element C12 is 7 add 12. Element C21 is 15 add 24. And then element C22 is 21 add 24. So together, what do we get? Well, we get 17, 19, 39 and 45. So that's our final answer. That's matrix C. So as I said, it is quite complicated, but practice makes perfect. So in this video we have looked at matrix operations, adding and subtracting matrices and multiplying them. Please do make sure that you are comfortable with these operations before we move on to solving systems of equations using matrices. Thank you for watching.